Hi, I am going to solve this circuit problem for Ix, Iy, and V0. So the circuit looks complex just on first glance, but it's not as hard as you would think. So the first thing to do with any circuit is we need a ground point. This is one ginormous node, all four of these points. So I'm just going to declare my ground here. Now I have a reference point. I have my ground. The next part is we need to determine if we're going to do mesh analysis or node voltage analysis. I am going to choose mesh analysis because nobody likes node voltage analysis. So to start, I need to declare currents in each of these loops. I'm going to go counterclockwise just because I feel like it. I1, I2, and I3. I've now declared three currents, I1, I2, and I3, and it's time to solve for these currents. I'm going to write equations starting with I1. For mesh analysis, I'm going to go in a nice counterclockwise circle and start writing different parts of my equation as I go. So let's start down here. I start going, I've hit a voltage source. So the current is going into the negative end of this voltage source. So my equation is going to start -50. I keep going, I've hit another voltage source. It's dependent, but it's still a voltage source. The current is going into the negative end of the voltage source. So I'm going to subtract again, and its value, 20Ix. Keep going. I've hit a resistor. Now, for this resistor, it's shared between two loops. So instead of usual just I1, we also have to take into account I2, which is going in the opposite direction. So we're going to take the resistor value, 18, and we're going to multiply it by the current, I1. But because we have a current going in the opposite direction, I2, we're going to have to subtract I2. And then all of that is equal to 0. We have our first equation. Our second equation, we analyze I2. As I2 is going around, we'll start going clockwise again. We start down here, we start going, we've hit a resistor, the 18 ohm one. Once again, it's shared between two loops. So the value of the resistor, 18 times what's our current, I2, but there's a current going in the opposite direction, so we have to subtract it, minus I1. So we keep going. I've hit a voltage source. This time I'm going into the positive end of the voltage source. So I'm going to add what? The value of it, 5Ix. I keep going. I've hit another resistor. This resistor is also shared between two loops. So I'm going to do the resistor value, in this case 40, times our current, which is I2. That's the loop we're going around. But we need to subtract the current going in the opposite direction, I3. And then I'll have all of this equal to 0 again. We have two equations. Now for I3, we start here, we start going. Here, we hit a resistor, 40, but once again, it's shared. So we do the resistor value, 40, times our current that we're analyzing, I3, minus the current going in the opposite direction, I2. We're going, we have a current source. So what's nice about this is we're doing mesh analysis, right? And in the case of this, where we have a current source, we know what the current flowing through this branch is. No matter what happens, it will always be 8Iy because of this current source. And because I3 is part of this, we know that just automatically that I3 is going to equal 8 IY. Once again, we have a current source. It's going through its own branch. There is nothing else here. We have the voltage source, we don't care. There's no other current thing. There are no resistors, no shared loops. The only current flowing through this is 8 IY. And so I3 is going to be 8 IY. So I don't need this equation anymore. We have 3 equations, but we have a problem here. We need an equation for every variable we have. We have 2 extra variables, Ix and Iy. So we need 2 more equations. So let's find those. Iy is the current going through this branch, this resistor. Now we noted that through this branch, I1 is going and I2 is flowing. Iy is going down in the same direction that I1 is flowing. And I2 is going the opposite direction. So we write the current that's going in the direction Iy is going, I1, and we subtract I2 because it's flowing the opposite direction. And then that will equal Iy. I1 flowing in the direction of Iy through this branch, I2 flowing the opposite direction, we subtract, and the value of the difference will be Iy. And we can do the same for Ix. Ix is the current through this branch. What current is flowing in the direction of Ix? I2. So I2 is the positive part. What's flowing in the opposite direction? I3. Subtract I3, and that's going to equal Ix. We now have all 5 of our equations that we need. We can solve for each of them. So let's do that. I am just going to punch it into my calculator because ain't nobody got time to solve it by hand. It is very important that you do not mess this up if you are entering it into a calculator. It can be very easy to do so, so just be careful in general. Because if you mess up, rip. I have a TI-84 calculator, so personally, I just use a matrix to solve for equations. I think it's the easiest way, at least in my opinion, for me to solve basic system of equation problems. Nice and easy. Sorry about the dog in the background if you can hear that, but it is inevitable. I cannot stop that. Let's see, negative 40. Negative 1, 1. Okay. A reduced echelon form. Okay. All right. My values are numbers that are not ridiculous, so that is a good sign. It doesn't mean you're necessarily right, but it is very comforting. Now we see that Iy is 5 and Ix is 2. Assuming, since everything is in volts and ohms up here, the units, never forget units, teachers and professors will get mad at you, is just going to be amps. Box it, call it a day. Or almost. We have one last thing we need to solve for, and that's V naught. So let's go back up and look at V naught real quick. We see V naught. We have a plus and minus, and then V naught in between. That means V naught is the voltage drop across this resistor. And we know, by Ohm's law, V equals IR. So, the voltage drop across this resistor is the current going through the resistor times the resistor's value, which will end up being V naught. So, our resistor value is 40. So let's go down here. We have V naught equals AR. V naught equals the current flowing through it is IX times the resistor value 40. What's IX? We now know it's 2 amps. So this is V naught equals 2 amps times 40 ohms. V naught is equal to 80 volts. IX, resistor value, 2 times 40, V naught is 80 volts. So send me a message if there are any problems. Once again, sorry about the dog, and I hope this helped.